So this is station 1, or reaction 1, of the chemical reactions lab. Your lab handout has a list of all the chemicals that are used as the reactants. It's got their names and formulas. You'll get to figure out the products, of course. It also has their states of matter to help you, and while it's not relevant for you, in this situation, it does have some safety information. So the first reaction I'm going to do is the decomposition of hydrogen peroxide. So here's some 6% hydrogen peroxide, which is roughly double the strength of what most of us have at home. And I'm just going to pour a small amount into this test tube. To speed up the reaction, I'm going to use manganese dioxide, or more properly manganese 4 oxide, as a catalyst. So one of the things you'll want to keep in mind when you write your reaction is, where do you write a catalyst to indicate that's its role? I'm going to just put a small amount on the end of this wooden splint and let the reaction go. I'm going to hold my thumb over the top to collect the gas that's being formed. And then I'll take a lit splint, I've got a Bunsen burner off to the side, blow it out, and while it's still glowing, put it back in and we'll see what happens. So I can see some bubbling, which indicates I'm making a gas. So I'm going to light the splint, still keeping my thumb over the top. You can see the splint's lit. I'm going to blow it out and then put it in the test tube top. So that's out, it's lit. Blow it out, put it in, and it relights. Blow it out, put it back in, and it relights. One more time because it's kind of fun. That's known as the glowing splint test, and at one time it was used as a way to test for oxygen gas. In this reaction, we're going to take a piece of solid magnesium metal. It's a nice malleable silvery metal. I can bend it. Put them in a pair of tongs and place it in a Bunsen burner flame, and we'll observe what happens. You notice at the end of the reaction, instead of having my shiny silver magnesium, I have this white kind of flaky powder. So I have a lot of evidence there that a chemical reaction took place. I had the production of light, a kind of energy. I had an obvious change in the physical properties of the materials. And your job will be to write a balanced equation and decide what type of reaction this is. And the directions will tell you real clearly how to do that. In this reaction, we're going to take some sodium bicarbonate, or sodium hydrogen carbonate, commonly known as baking soda, heat it up in a test tube over a flame, and see what the gas that's produced does to a flame. So I'm just going to put a few scoops in. It doesn't take much. I'm going to place this in the test tube. And you actually won't notice anything coming off, but it's decomposing and making a gas. I'm going to take a wooden splint and light it. And while it's still lit, I'm going to place it into the mouth of the test tube. And you notice it's gone out immediately. And what's happened is, in that reaction, we produced a gas that puts out a flame. And your job will be to write a balanced equation and explain a couple things when you answer the questions. In this step of the reaction lab, we're going to react a piece of magnesium metal with some aqueous hydrochloric acid. So I'm going to put the magnesium metal in a test tube. I'm going to pour the acid in, and then to collect the gas that's produced, I'm going to put a second test tube on top like this. So almost like a lid. And then I'm going to take this test tube and introduce a lit splint into it, and we'll see what happens with yet another gas that we can produce. So put in a couple droppers of hydrochloric acid. I'm going to put this on as a lid, essentially. So I'm collecting the gas. And I'm going to light the splint. And I'm going to take the gas that I collected and put it into the mouth, the test tube, and you heard a pop. And that's sometimes called the pop test, and it's used to test for hydrogen gas, which means I just gave you one of the products. If instead of a little test tube full of hydrogen, I'd had a giant blimp, we could have recreated the Hindenburg, but apparently school administration is not too big on large flames going on in the building. Go figure. In step 5 of the reaction, we're going to combine an aqueous solution of potassium chloride and an aqueous solution of silver nitrate. And I'm just going to take a dropper of the potassium chloride, and you can see it's a colorless liquid, a solution, and it's clear. Colorless means it has no color. Clear means essentially that it's transparent or you can see through it. I'm going to take a dropper of the silver nitrate now, and let's watch what happens. So what you'll notice is the bottom of the test tube now has a white cloudy material. That's actually particles of a solid that is not soluble in water, and that's known as a precipitate. And it's called a precipitate because if we wait a few minutes, it's going to sink down, kind of like precipitation falls from the sky. So in this case, I've made a white precipitate. And what you'll be able to do is figure out what type of reaction this is, figure out the products, and then by using your solubility chart, you can figure out which of the chemicals made was the white precipitate. In general, if you have a precipitation reaction, there will only be one precipitate. So once you know which chemical is the precipitate, you can figure out which one is not, kind of by the process of elimination. And I don't know if you can see that, but the top of that test tube is actually getting a little bit lighter as the precipitate sinks down or falls to the bottom. So reaction 10 is the reaction of lithium carbonate and barium nitrate solutions. So we're going into the test tube. Here's my barium nitrate solution. One dropper is enough. Here's my lithium carbonate solution. And you'll notice we've gone from a clear, colorless solution. We've made that white cloudiness. So once again, we have a precipitation reaction. Your job will be to write the balanced equation, tell the type of reaction it is, and identify the precipitate based on your solubility rules. In step 6 of our reaction, we're going to take some silver nitrate solution, and I'm going to add a piece of copper metal to it. Looks a little like a copper BB, because it is. And you'll notice the copper is kind of a shiny copper-colored piece of metal. So I'll get another one because I dropped that one. I'm going to drop this in. And this reaction might take a few seconds to happen, but what's going to happen is the silver ions in the silver nitrate are going to actually react with the copper metal, and you might be able to notice that the piece of copper is getting a little gray in color. Let's see if we can zoom in on that. Oops. I'm not sure. Let's zoom back out. And now you can, there's almost a gray fuzz on that copper BB, and that's pure silver. So what used to be silver ions is now silver metal. And if we wait a little bit longer, you'll actually see a faint blue color come into the liquid. And that's because what used to be copper metal is turning into copper ions, and copper ions, when they're in water, have a bluish tint to them. So your job will be to figure out what the balanced equation is, what type of reaction it is, and then use your states of matter to finish everything up. So for step 7 of the lab, we're going to take a copper 2 nitrate solution and a sodium hydroxide solution. And we're going to combine them in the test tube. So we take a dropper of copper nitrate. And this would be described as clear and blue, because we can see through it, but it's got a blue color. And then here's my sodium hydroxide. Going to add this in. And you'll notice I've made another precipitate. You can see now it's cloudy, light's not going through. So your job will be to write a balanced equation, figure out what type of reaction this is, and then using your solubility chart or the solubility rules you've learned, figure out which chemical is the precipitate, and remember that there will only be one precipitate produced in these reactions, so you'll know the state of matter of the other one is aqueous. You can see it's still liquid. So in step 8, we're going to react hydrochloric acid, or aqueous hydrochloric acid, with aqueous potassium hydroxide. So I'll put the hydrochloric acid in first. Now I'll add the potassium hydroxide. And in this case, I don't see any obvious changes. It's a little bit warm, which might be a clue that something's going on, but I didn't make a gas and I didn't make a precipitate. However, this is a very, very important type of reaction that shows up in chemistry. We've reacted an acid and a base. So one of the questions you'll be asked in this lab is, even though you didn't see anything happen, what could you test to tell you that a reaction had in fact happened between an acid and a base? So in step 9, I'm going to place a little bit of methanol, sometimes called wood alcohol, into this watch glass. The directions say to use an evaporating dish, but we'll use this. I'm going to take a wooden splint, light it, bring the flame over, and you'll notice it's burning. If I hold my hand even 2 feet high, it still feels very hot. And that'll give us one of the useful products of every combustion reaction, which is why you have that Industrial Revolution chapter in your history books. So this was methanol, CH3OH, and I didn't add another chemical, but because it's burning, that means it's reacting with oxygen in the air. And remember, oxygen was a diatomic element, and from your notes and examples you've seen in class, you should know what the products are of this type of reaction. And last, for our reactions lab, we're going to do the combustion of isopropyl alcohol, commonly known as rubbing alcohol. What most of us have at home is 50 or 70%. This is essentially 100%. I'm going to pour a few drops into the watch glass, get a flame, bring it over, and watch what happens. It looks very, very similar to the methanol. The products happen to be the same. And remember, this is not being heated. This is actually burning. So when something burns, it's reacting with diatomic oxygen in the air. I don't have to provide the oxygen. The air already has it in it. So when you burn gasoline in your car, you need the right mix of air, the oxygen, and the fuel. We tend not to think about the oxygen because the air provides it, but if you have an incorrect mix, your car won't run properly.